Okay, tell me your name one more time.
My name is Hassan Basajic.
Okay, and what are you doing here in Antarctica?
I'm a science technician for the long-term ecological research project in the McMurdo Dry Valleys.
And what specifically does that entail?
I take care of several weather stations. There's about 14 of them, and I maintain all the sensors on there and make sure that they're running. So I visit each station, download the data, and make sure everything's running smoothly.
And what kind of sensors are out there?
We've got air temperature, usually at 3 meters, as well as our relative humidity, and then we monitor the amount of light coming in at each station as well. So we have incoming shortwave radiation, and then what's being reflected off the ground, as well as at some stations long-wave radiation, and both incoming and what's being given off by the ground. And in addition to that, we also have certain sensors on some of the land-based sites that measure the photosynthetic range that's important to plants. And so it's a certain wavelength that we monitor for the folks that are interested in the biology.
Cool.
And then we also measure precipitation, and we've got several weighing buckets that measure the amount of incoming precipitation. And then we also have these sonic rangers that measure the distance from the sensor to the ground. And so those actively, they send out an acoustic pulse, and they tell you how far it is from the sensor to the surface. And if snow accumulates, then we could assume a certain density of the snow and get at an accumulation, and then see how long that snow potentially sticks around.
Anything else?
I'm going through the sensor in my head. Air temperatures. So we also measure, on the glaciers, we measure ice temperature at various depths to see how it changes. And then on our land-based stations, we measure soil temperature, both at the surface and then at 5 centimeter increments down to 20 centimeters.
And then classic weather things like wind speed and velocity,
and so
direction.
Wind direction, wind speed, and that's taken every 4 seconds, whereas all the other measurements are taken every 30 seconds, and then all averaged up into 15 minutes. So we have continual 15-minute data year-round.
So you said that some of the places were on glaciers and some of the places were on land. Can you just kind of describe a couple of the places where those things are located?
Sure. All the stations that we have, our project is based here in the McMurdo Dry Valleys, and the valleys are made up of Taylor Valley, Wright Valley, and Victoria Valley, as well as several others, but those are the ones that our group focuses on, and mainly our group focuses on the Taylor Valley. So the valley runs east-west, and we have a total of 14 stations now. So the majority of them are in Taylor Valley. There are 4 that are on glaciers, on Commonwealth Glacier, Canada Glacier, Howard Glacier, and then up at Taylor, where we were the other day. And then in between all those, we have land-based stations as well. And so they vary. Most of them are near the lakes, which folks are studying, and then others are more remote, and going up as far as Beacon Valley, which is the last dry valley before you get to the plateau, the polar plateau.
So how long has this stuff been being measured?
Well, it's a long-term project, so you need water?
No.
Oh, for me? Yeah. It's a long-term project. So the LTER started here in 1993-1994 season, and so some of the stations were put in that year, and they've been running ever since. More and more coming online up until about 2003, and then we've kind of settled at 14 stations now. Some of the stations that we acquired were from previous researchers, so our record goes back as early as 1986 here at Lake Hoare. So that's really valuable information.
And what's the purpose of doing all this?
Well, the broader purpose of the LTER is to understand the ecosystem, since we're considered kind of an end member of the ecological spectrum. We're in a polar desert, so it's extremely cold, it's water limited, and then for half of the year it's light limited. So what looks like a somewhat of a dead place is actually a very simple ecological ecosystem. It's a simple ecosystem. So you could study the processes very simply, whereas in more complex systems, it can be difficult to pull different things apart.
You mean like systems that have humans involved?
Yeah. Well, there could be an anthropogenic presence, or just that there's a whole lot more going on. Where here in the dry valleys, the as we talked about, largest critter, so to speak, is the nematode, which is a microscopic worm. So everything else happens at a much smaller level than other things. We don't have grasses and trees and things like that, so we don't have any large mammals except for things that are passing through very quickly. So yeah, it's basically the purpose of having all this climate information is so that we can understand if there's changes that are going on, and then we could look at how the ecosystem responds to those climatic changes, both on the short seasonal term and on the longer term. So,
how does that tie into this energy balance thing? Is ecosystem and energy balance kind of the same thing, or?
Energy balance is different, and energy balance is, as we apply it, is to the surface of a region. And the most important for us, why we look at energy balance, is the main limiting factor for the dry valleys is for life in the dry valleys is water. So we want to keep tabs on where water's coming from, how much, and when it's coming into the system. And so my other half.
Go over here.
So my other half of the job is monitoring the glaciers, and we monitor the glaciers twice a year. When we first come in, we measure stakes that are put into the glacier, and then we measure them again at the end of the season, and we look at that change. And so we have an idea of how much ice is being turned into water, and potentially can enter into the lakes and the streams and lakes. And so that water can then be used. So that's the main reason why we got into energy balance, is because understanding what's happening at the surface of the glacier, you can model then how much melt water is entering into the system.
So energy balance means melt, or it means how much heat is getting generated?
Yeah, energy balance is in a broad sense, how much energy is entering into the system and how much is leaving. And so if you have extra energy into a surface, then you have energy available for ablation, either sublimation or melt.
Oh, okay.
And so you look at the different parameters. So you have shortwave radiation coming in, and then some being reflected, and that reflection gets into albedo. There's long wave radiation, which again is being reflected off of clouds and then entering into the surface and then being given off by the surface. And then you have two fluxes. You have latent heat, and it's going to take me a second to recall the other one now. Yeah, I'm not going to remember the other one right off the top of my head right now. But you have these two fluxes that are dependent upon wind speed. It's going to bother me now. But basically, you have these components, and when you balance them out, if you have any excess energy, that's what's available for ablation.
So, how do you? I guess I'll ask you this one first. What's the difference between measuring all these parameters for climate and